this was our first feet wet into doing that. And since 10.4 we're only doing today, and I don't even know if we're going to finish it completely, I extended that one to Wednesday. So there's a couple of homeworks due, I guess 10.2 and 10.3 on Sunday night. You probably will be able to do all of 10.4 by Sunday night as well, but if you need some more time. All right, so yeah, I guess any questions from you guys? Anything going on? Yeah.
Question about are you still not going to let us go back?
So the question was that policy of not having a back button basically on the exam. I haven't heard anything different, so yeah, it seems that way. I don't really love it either, but I guess it hurts everyone a little bit equally, so yeah. And the scores are lower than they have been in the past because of that exact reason. And also no parking credit, those two things. All right, anything else? All right. Nothing new by me, really. We had our math tutoring center scavenger hunts. I put on there one of the questions was I gave them random objects, and one of the tasks was to barter at like the C-store or something, to barter for food. I got some of the most hilarious videos. This one kid got just like a Texas mug, and he bullied this kid out of their entire chicken dinner. He's like, oh my God, Texas is the second biggest state, you gotta have this mug. So he was successful. And this other group, I gave them a potato plot, which was actually pretty hilarious because they went to the like the cashiers and tried to barter directly with the store for food. And they were just like giving them so much sass. They're like, this potato plot, just give us a couple bags of M&Ms. And he's like, so wait, first of all, I gotta buy a potato. They're like, yeah, but then you'd have a cool plot. Like, why do I need a potato plot when I got this cool Apple Watch? They're like, think of your kids. My kids are 40 years old. So that was what we did last week. Good times. Anyway, anything new and exciting your way? Any fun stories on campus or just, yeah, quarantine? Is anyone in Laurel that has to be tested today? I heard that they're testing all of Laurel Hall for COVID. Right. I heard that. Are you in Laurel?
Yeah.
Oh, I may have heard wrong, but I just heard.
I got tested last week. So.
Everyone, or just you?
No, I did for the baby brand.
Oh yeah. Maybe they let you slide since you already in. Anyway, so I guess not much else is new there, so let's get on to comparison tests. Good news and bad news about this. Comparison tests sometimes give people a little bit of trouble. I guess that's the bad news. But the good news is it's really exactly the same process and the same logic that we use for the integral comparison tests. So let's do it. It's basically an analogy for series. And the basic idea is it's going to be comparing the terms. We're strictly going to be looking at positive series just so we don't have to deal with negative signs, and that throws everything off a little bit. So comparing the terms of a positive term series, we'll have this form. So we'll call it the summation of a sub n. Limits don't really matter except for the fact that it's got to be an infinite series here. Summation to infinity. With those of another positive term series, called the test series, whose convergence we know. So comparing those with lost the word. Comparing those terms with those of another positive term series, whose convergence is known. this, we're going to typically use things like a p-series test or an easy geometric or things that are relatively simple and that we can easily tell if they converge or not. So I'm going to just put here some of the common reference series. Reference just means the thing that you're going to be comparing. So I would say the most common ones are the geometric. It comes up pretty frequently. Remember, this is a summation of a times r to the n power, which, if you recall, converges as long as that rate is less than 1. And it diverges if the rate is greater than or equal to 1 in absolute value. So that's your geometric. P-series is the most common by far. I'll put a star around that one. Simple one, right? Just of the form 1 over n to the p power. And this converges if p is greater than 1, and it diverges if p is less than or equal. Right, so kind of like a little review of our little stuff. And just going to put a quick note here. And this, I guess, is a general comment, but in general, only use the highest order terms in the numerator and the denominator. Highest order terms in the numerator and denominator. I guess I'll say in general. So the first two are very common things to compare to. The last is more just a general idea. If you just cut out all of the lower order terms, try to compare it to that if it makes sense. And there is a little bit of flexibility that you have to have here. Sometimes you'll try to compare it to something and it won't work, and that's fine. You might just have to try something different. So let's start off with, we've got the same two tests as before, the direct comparison test. And when that fails, a limit comparison test. Just as before, DCT for direct. And it says basically the following. So let's suppose we have a summation of a sub n, again, it's an infinite series, and another summation, b sub n, again, it's an infinite series. And both of these are positive term series. Okay, so here is what the direct comparison test will directly state. So if a sub n is greater than or equal to b sub n for all values of n greater than or equal to k. This is kind of similar to the question before that someone had, I guess, on the integral test. As long as one of them is always bigger than the other for some value ever after, that's pretty much all we need. The problem stems from the fact that we have infinite terms. If I have something weird happening in the first 5 terms or a finite number of terms, that's not going to make too much difference. So as long as it's the first one is always bigger than the second one at some point, then the following is true. Then, if the summation of b sub n diverges, b sub n is going to be our reference series. Then, let's see. Again, let's just go through the logic here. So b sub n, the summation of that diverges, and a sub n is always bigger than b sub n. So it's got to end up adding up to something bigger than this thing that diverges. Therefore, it has to diverge too. So results here, the summation of a sub n must also diverge. Okay. The opposite is not true, right? So just by this, I'll put it in parentheses. If instead b sub n converges, we would conclude nothing in that case. Generally, we'd probably go to LCT in that case. But again, just running through the logic, if we know something converges and something else is always bigger than that thing at every single term, then it could add up to something a little bigger, or it could add up to infinity. You do not know. And then the opposite case. If, on the other hand, a sub n, the thing that we're trying to figure out, if it's always less than the thing that we know what it does, the comparison test, or the comparison series rather. And again, this is technically true for all values of the terms after some point. Usually in our case, it's just going to be true for all values. Don't even really need this clause. Then the result is this. Then if the summation of b sub n to infinity converges, all right, again, going through the logic, this thing converges, and the thing I'm looking at is always a little bit smaller than that thing. So if this converges to some number, then the summation of the a sub n has to converge to a smaller number. So then if a sub n converges, the summation of a sub n must also converge. And I'll put in parentheses the opposite, which is going to be true as well, that you conclude nothing if it's the other way around. Note, if the summation of b sub n diverges, in that case you conclude nothing. So a lot of wordiness here. Hopefully it's stuff that looks familiar to you. Again, one last time, logic on this one. A sub n, b sub n adds up to something that goes to infinity, and a sub n is always a little bit less than that. Well, it could add up to just a little bit lesser of an infinity, or it could add up to just a finite number. We don't know. So that's like the key logic for comparison tests, and a lot of series stuff comes down to this. So hopefully it looks familiar. But if you want to go through any of the logic again, since it is so important, let me know. Again, it should be nothing that you really memorize here. It should just be that you understand the logic, and then you can kind of replicate that logic at any time. So we got 20. I actually got a much cheaper today, which is unusual. So does that look okay? So I'm just going to do one example and give you one example, and then we'll just go right to the limit comparison test. The section is designed in 2 homework sections, and I think the first one's like all the DCT, the second one's all the LCT. You might even want to just do them in like mixed matched order, because the whole point is trying to figure out what to do in these cases. So I don't really want to just go through a million DCTs and then followed by a million LCTs. I want to just introduce them both, and then we can figure out which is appropriate as we go through each one. Okay, so converge or diverge. I'm going to write that as an abbreviation. What I'm going to do is summation n equals 2 to infinity n over root n cubed minus n. First thing, notice the directions, right? I mean, I wrote it in abbreviated fashion, but it just asks, does this thing converge or diverge? It doesn't have the additional clause there that says, if it converges, find out what it converges to. So that's kind of a tip-off that you might not be using geometric or telescoping possibly, and it does indeed not look like either of those two. So comparison test is a good one to use because we've got lower order terms. Anytime you've got lower order terms, it just kind of makes sense. Okay, let's drop them and compare to something. So this is my a sub n, and I'm going to compare it to n over root n cubed. Right, that's the exact same thing with the lower order terms. Drop. I wouldn't simplify anything here. I'll do that in the next step so that you can easily compare the two. Which of these two is bigger, left or right? Left, 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 everyone left. Good. All right, so we're a lot better at that than we were when we did it with the integral stuff. That's good. And again, if you weren't sure about that, this one has the smaller denominator. So when you divide by the smaller number, it gets to be the bigger side. Okay, so we have that. Now we have to figure out what this summation would do. So now let's simplify it. So this is n over n to the 3/2, which is 1 over n to the 1/2, simplifying it down. And if I were to look down, now here's some of the details that I'll be picky about on our quizzes, you'll see. This would not be a correct statement, so I'm just going to write something wrong, and then we'll discuss why. So what if I said this converges, no, that would just be code. This diverges by p series, where p is equal to 1/2, which is less than or equal to 1. You lose a point on this for this work. Anyone have a guess why? Seems right? Here's the technicality. This thing right here is not a series yet, right? This is just an expression by itself. It's the summation of this thing over all the terms that is a series, and then that thing diverges. Okay, this is just a number. So you do have to write everything in proper notation and logic. So we can say that the summation of 1 over n to the 1/2 from n equals 2 to infinity, that diverges by a series. Now, this diverges, and this is always bigger than this. So by DCT, this one also has to diverge. So, original series diverges by DCT. So let me give you the one to try out. Summation n equals 1 to infinity, 2 root n over n cubed plus log n. Yeah. No, this is all right. You just needed to write this, that this summation is what diverges. It's not just this expression, because that doesn't mean anything. So all this is the correct thing to write, but it needs to be talking about this. Thanks for clarifying. Welcome back. A little while. Not really. You crashed into 2 separate cars in there?
Yeah, my mom started first, and he like.
Okay. Took the whole time. Welcome back. If anyone wants me to check their work, you should get that this one is, I think, converging by DCT. DCT should work. This 5/2 is bigger than 1. You guys good on there? Any questions? By the way, just a quick hint, when you're comparing to the comparison series, when you can take the largest term in the numerator and denominator, I would include with it any coefficients. Otherwise, it makes it more difficult to compare. So this should have been compared to 2 over root n over n cubed, which is basically 2 summation 1 over n. Right, the coefficient can come outside the sum. It's not going to change anything. So you'll get that this converges by p-series, and you should get that this is less than this. Therefore, that the original converges as well by DCT. So any question with that? All right, so one last minute. People are looking for maybe finishing up, and then we'll do else. Actually, while people finish up, I'm just going to write the theorem out for LCT, and I'll talk through. If you want to get a jump on topping down, I'm going to jump on right. Alright, so assuming we're good up through there. So here's the LCT. Basically, it's just like what we did with improper integrals. We kind of use it when DCT fails. And we try and pick the natural thing to compare my series to. If DCT works, great, and the problem's done. But if not, I'll proceed on to LCT. Purpose of LCT and the theory behind it is the natural comparison series should move at the same rate, right? The term should be decreasing at the same rate as the original. So if I took the limit of the a sub n and the b sub n, which generates those terms, and found that the rate, basically that limit L, is somewhere between 0 and infinity, then if one of them converged, say to a number 5, then the other would just be L times that number 5. So both series would behave the same way. Obviously, if one diverged to infinity, then L times infinity would be infinity anyway. So if they diverge, the other one will diverge. One converges, the other will converge to a slightly different number based on that proportion F. All right, so the end result here is if your limit ends up being between 0 and infinity of that ratio, then either they both converge or they both diverge. But succinctly, we could just say that they behave the same, both series behave. So a couple of the opposite cases, if I get 0 or infinity from this limit, then you chose something that just, it moves faster or slower than the thing you're trying to look at by an order of magnitude, and therefore the things just don't behave the same at all. So limit comparison test wouldn't tell you anything. So I guess I should add that at the bottom. If L is equal to 0 or L is equal to infinity, we conclude no. And again, that's just saying that the series moves so differently that they're not even really worth comparing to one another in this map. Last question, again, this is kind of repetitive because we did it already, but the order in which you divide here in the limit is completely irrelevant because imagine you got a limit from this quotient. If I flipped it, I would just get a number 1 over L, but it would still be a number between 0 and infinity. So any number and its reciprocal are going to have that same property. If the limit ended up being 0, the reciprocal of that would have went to infinity, and infinity would have gone to 0. So the fail cases would just flip, but they'd both be fail cases. So in that result, the order in which we divide is irrelevant for us. All right, so now I'm going to just mix things together. So the first one will be LCD. But yeah. After this, it's just going to be a mix. So you tell me what you think is the result as we go through. So how about summation n equals 2 to infinity, 1 over n to the 5th minus 1. Now, before we actually start this problem, I want to just chat about something that I want you to start developing over the next couple weeks. And that is your best guess as to what the series does before you even write a single thing. What do you think this is going to do, by the way? Without doing any work or thinking ahead, what do you think that's going to do? Why do you say converge? Okay, so you said the n is at the bottom, and if I look at like limit as n approaches infinity over this, it's going to go to this, right? Now, is that a meaningful thing? Oh, but that still goes to 0, right? Infinity minus 1. This limit will go to 0. Yes. But basically, what did we do here? We actually kind of just did a test. You got an idea?
Is that for the last row?
Well, it is a test for series. Basically, what you did here is the nth term test, right? And what is the result of the nth term test if you get a 0 in the limit? Does this mean?
No.
You do not know, right? So basically what you did is the nth term test for divergence. If you got anything but 0 here, then it diverges. But in this case, you get a 0, which means I have no idea. This is just basically saying the terms do go down to 0. But I don't know if they're going down fast enough to actually, the sum of them converge to a number. Right, so I'm going to kind of keep reiterating that point as long as people are not 100% on it. That doesn't actually help us. So can anyone else give a rationale as to why this would either converge or diverge without looking and doing anything?
You can use the beta, that's the use paradigm.
Okay, that's the basic idea. So you're saying that this converges or diverges? Converges?
Yeah.
It does, it is going to converge. It's basically, and forget the lower order terms, it's basically 1 over n to the 5th. So it's something that's going to converge, right? So I would hope that, after 2 weeks or so, you should, by the time you take the third exam, be able to look at probably 90% of the problems and say, I know what's going to happen before you even start. And that should help you, get to the right spot. But now going through the actual work to prove it, I'm going to drop the lower order terms and compare this to 1 over n to the 5th. Bigger is, well, smaller denominator here means that is the bigger side on the left. So this is already in a form that is a series I know. Summation 1 over n to the 5th converges by a p-test 5, easily greater than 1. It's going to converge pretty easily, actually. Now, does DCT work? This converges, and this is always bigger than it. So DCT fails, right? This converges to a number. This could be a bigger number, or it could be infinity. We don't know. You don't have to write that DCT fails, but I'll always do it just so you can follow the logic. So let me try LCT. Limit n goes to infinity of 1 over n to the 5th minus 1 over 1 over n to the 5th. I just divide into two series that we're going to compare in some order. So this is limit n approaches infinity of n to the 5th over n to the 5th minus 1. I guess you could do like a bunch of L'Hopital's here, but you could also just divide by the highest power, top and bottom, which is 1 over n to the 5th. Gives you limit and goes to infinity of 1 over 1 minus 1 over n to the 5th. 1 over n to the 5th is 1 over infinity, so that goes to 0. This limit all just simplifies down pretty easily to 1. And that's your limit. That's what and it is clearly between 0 and infinity. So based on that, we can say that the original series must move at basically the same rate as the comparison series. And the comparison series converges, so this one also has to converge.
Professor, sorry, my Wi-Fi cut out, but why did we do all this, and why couldn't we just solve the summation right away?
Let me just write out the final answer and I'll get to your question, but both series behave the same. So original series converges by LCTA is what we can write. So what do you mean by why don't we just write out the summation from the beginning?
Cause wouldn't it just go to 0? Cause it's 1 over infinity minus 1.
You're talking about this limit?
Yeah.
But that's basically, yeah, that's what you missed. This is the nth term test. And the limit of the terms going to 0 is inclusive of nothing. So, quick note as a comparison, right? This summation, n equals 1 to infinity of 1 over n, that also goes to 0, right? The terms go down to 0. But we've already proven that this is a divergent sum. So just because the thing is declining doesn't mean that the sum of all those terms adds up to something that is finite.
Oh, okay.
so how does that look? So yeah, just be careful to make sure that you're careful with writing things out. It can get frustrating when people can look at the problem and say like, well, I know it's going to converge, and then they get kind of sloppy about writing all the pieces. So don't think about these problems as like trying to find an answer. Think of these problems as proofs, right? Most of the time you'll know what the proof is going to be. Again, you just have to show all the steps to actually prove it up. And let me do one more. Summation n equals 1 to infinity of 1 over 2n plus ln n. Okay, does that converge or diverge? So once again, it's not geometric. You can't do telescoping series with that. Integral test is honestly like the last thing you're going to think about. So it's not integral test. You wouldn't want to integrate that. You see the lower order terms, and you should kind of immediately think value comparison. Let's drop the lower order terms. So in this case, we know that n grows faster than ln n, but it's going to compare it to 1 over 2n. 1 over 2n plus ln n. I'm going to compare it to 1 over 2n. And then which one is bigger, left or right? Disagreements. We got a right from online. Who says a right? Right, yes. Notice that this one is the bigger denominator, so that makes this small when I divide. Okay, let's say what this does. If I pull the 1/2 out, I get just summation of 1 over n. I could say that's a p-series that diverges with p equals to 1, or I could just say that this is a special case, right? This is called the harmonic series. So I could just say a divergent harmonic series. So there's that. The thing I'm looking for is smaller, and the thing that I know which diverges. So being smaller than infinity, don't know what that means. Could be a smaller infinity, could be a number, what DCT does. Now LCT. So we get 1 over 2n plus log n over 1 over 2n. Which, if I flip it around, gives me a limit 2n over 2n plus ln n. All right, what would you pick to do for evaluating this limit? I have a couple choices here. Okay, yeah, we could do L'Hopital's rule, right? This is infinity over infinity. Note that it's infinity plus infinity in the denominator, so that's acceptably infinity. So L'Hopital's would give us this, which is limit n approaches infinity of 2 over 2 plus 1 over n. Derivative top to bottom. So 1 over infinity goes to 0. I get 2 over 2, which is 1. That's my limit. So I do get that the limit is between 0 and infinity. And I can say, again, both series behave the same, which means, therefore, that the original series does what? So, original series, this one, diverges or converges? Converges? Diverge, because they're comparing it to something that diverges. Right? That's a very common thing that people will kind of mistake. They'll get the limit to be successfully between 0 and infinity, and people kind of like in their mind equate successful with converging. It has nothing to do with that. This just means that they do the same thing, whatever the comparison series did. So the original series diverges in this case. Yeah.
How is anything
Yes. Yeah. All that means is basically, imagine that the summation of the first one ended up being 20, right? And then your L was equal to like 5, right? That just means that the one of the series is always pretty much like 5 times bigger than the other one. So if all these terms added up to 20, and every term was 5 times bigger, then this one would just be adding up to something 5 times bigger. That's the basic idea of it. You may kind of wonder, by the way, it seems like we always just keep getting L equals to 1. And the reason for that is because we match the coefficients perfectly. All right. If I had chosen to compare to just 1 over n, for example, then this all would have shaken out to 2. And you get the same thing. Yeah.
Is it possible to use the consistency?
Is it?
Is it possible to either do calcII or consistency?
Yeah, sure. You could just ignore this if you want. I don't really recommend it because if DCT works, it costs you nothing. You just have the answer. So you might as well check for DCT. But if you don't want to, you can just go into LCT. Sometimes you actually can't check for DCT at all, though, because sometimes basically you just pick something to compare and you actually have no idea which is bigger because it's not really clear. So then you kind of just have to skip DCT and go right to LCT. But yeah, it's not specifically a precursor that has to have. Yeah.
Harmonic series is going to be equal to 1.
Yes. And you don't have to call it that. It's just if you do, it's valid. If you want to call it a P series, P equals 1, it's fine. Okay, we're actually going to do the answer the question. Summation 3n plus 2n squared for n to the 4th plus root 14n. It's some ridiculously ugly looking thing. I think there's a question online though first. So Andreas says, so you basically know what the series is going to do from the original comparison, you just have to prove it. Yeah, if you make a good comparison, you should hopefully know what it's going to do. Now, that's not to say that sometimes people will choose the wrong thing to compare it to. So for example, Andreas, suppose up here, someone didn't know which was bigger, n or ln n. And they compared this to 1 over ln n. And they proved that 1 over ln n diverges, which it does, not by harmonic series, but by something else. And then DCT fails, so I go into LCT. Well, LCT would actually fail now because you chose the wrong thing to compare it to, and you'd end up getting a 0 or infinity number. So just because you think you're on the right track, you still do have to prove it because you might have made a mistake. That's a great question. How is it going to translate to exams? I don't know. I don't know exactly. So I'm going to actually message him and personally say, like, I think we should have a work upload on this one. I don't know if he's going to take that suggestion. We got a couple weeks to figure it out. But even if he doesn't, I will at least ask him, what are the problems going to look like? Because this is how I teach my class. We're a little confused. All right. Does that make sense? N is inside the square root. Okay, so let's look at this. You see all the terms, and so that you immediately kind of think, yeah, it's going to be a comparison test. Let's try that out. So 3n plus 2n squared over n to the 4th plus root 14n. What do you want to compare this to? One on top, first of all. 2n squared, right? Make sure you take the highest order term. And the bottom, clearly n to the 4th, right? If I were to simplify this down, I get 2 over n squared. And if I were to bring out the 2 and look at this as summation of 1 over n squared, this is a convergent piece of this. So converging by p-series where p is equal to 2, which is clearly greater than 1. So that's what the natural comparison series does, converges. So based on that, we're pretty sure this is going to converge. And again, you kind of could have seen this right at the beginning, because more or less it's like n squared over n to the 4th. So it's like 1 over n squared. It's kind of like the p-series that converges. You should immediately think that that's what's going to happen. Between these two, which is bigger, left or right? This one? Why do you say left? Because of the 3n? Okay, the 3n makes this bigger for sure, right? But what about this piece? The plus root 14n actually makes the denominator bigger, which makes this side smaller. So there's actually like 2 pieces here, and it's not really clear which one is always going to be more important than the other. So in this case, we actually have to put a question mark. I actually can't tell. That can be tricky for some people. Does everyone understand that there's 2 pieces here pulling in the opposite direction, so I actually can't make a comparison directly? And just to illustrate that point, all the people online said the right was bigger, all the people in person said the left. So you're just looking at different pieces, and you got to take a look at the whole thing at once. But this goes to your question, where we basically have to completely skip DCT because I can't even make the comparison.
Since the n goes faster than that, like n the one have, doesn't that just tell us that it's less than the other rate?
It's kind of tricky though, because I mean, you also have to compare it. So this growth rate is bigger than this growth rate, but you have to compare it to relative how much it's affecting this. So it's not particularly clear. You'd have to prove it out by calculus or something like that, which trust me, you don't want to do. It's much easier to say, I can't directly tell, we'll skip it and figure it out. Are any other thoughts with that? Because that does get people from time to time confused. Limit and approaches infinity. This is going to be a little bit messy. So we get 3n plus 2n squared over n to the 4th plus root 14n all over 2 over n squared. When I divide these two things out, I might as well use the simplified version. Okay, so coming over here, let's flip this. The 2 will go in through the denominator, so 2n to the 4th plus 2 root 14n, and the n squared will flip up to the numerator and go in through there, so 3n cubed plus 2n to the 4th. Now, how do you want to take this limit? Yeah, I would divide by n to the 4th here. L'Hopital's is going to go in a very bad way. It technically is valid, because it's infinity over infinity, but the roots are going to make a big problem, and it's not going to simplify down for a while. So let's divide by the highest order term, which is 1 over 2n to the 4th. You don't actually even have to divide by the 2. If you want to just do, maybe it's easier. Let's just do 1 over n to the 4th, 1 over n to the 4th. Either way would work. So we get limit n approaches infinity of 3 over n plus 2 over 2 plus, all right, so now we get 2 root 14 root n over n to the 4th, so that's like n to the 1/2 over n to the 8/2, so n to the 7/2 to the denominator. And when I evaluate this limit as n goes to infinity, these two terms, 1 over or 3 over infinity, 2 root 14 over infinity both go to 0. So I get 2 over 2, which is 1, which is my limit. So same deal as before, since L is between 0 and infinity. And again, you do have to put all these clauses and make sure that you show that you understand everything, certainly at least for quizzes. So since that's the case, I'm going to say that both series behave the same. Let me just write it a little shorter this time. Both series converge by LC2. Because the comparison series converges, therefore the original series converges. All right, so I think, yeah, I think I'm going to give you 3 to try out now, which will take us to the end of class. So we've basically officially finished this section. Like I said, you can feel free to do this by Sunday if you like, but if you want to take the one for this. So, do they converge or diverge? And remember, I'm going to start now, a lot of times in sections, giving you, 3 problems at the end. And they probably, at least one of them will have to do with the lesson we just did, but it could be a mix of all the tests. I want you to start getting used to thinking of all those ways that you could handle a series conversion. About 3 over 4 plus root n. That should be an easy one. Summation n equals 1 to infinity. 1 over n plus 3 quantity cubed. And third one, summation n equals 2 to infinity. 1 over n, ln n to the 5th. There you go, we got 25 minutes. Actually, that's a lot. I should put up a 4th one. Two n over 3n plus root n. Any questions for you on the online section? Oh, any of you guys question? Nora, no, I didn't record it. For some reason, I think just like wasn't recording right, but I think Mike records them. So you can double check with him if he's on. Let's see. Yeah, so there you can connect with Mike if you want the recording. No problem. You want me to stop by and just check out, look at what they're working so far? That looks good to me. If that works. By the way, you can actually go to Build Simpler and just take out the leading, try to lower or try to redundancies. And just you can compare this directly to this, right? You can see the same thing. You could, if you wanted to, compare this directly to this without more problem. Bigger. See, lower order redundancies. And we'll just take the last bit. So if you put equal signs, you could be comparing things that actually could be equal. So the summation has to be compared. Well, this is clearly a bigger denominator, right? So that's going to be smaller. The issue that you're going to have here, though, is that in this case, you're not dropping lower order terms, you're dropping part of factors of the actual term. Right? So this is not moving at the same rate as this. They're going to find fail. So notice here, there's things added or subtracted, those are easy to drop. There's things multiplied by, or stopping it is not gonna change the nature of the comparing. So it's actually comparison test. Yeah. By the way, if anyone wants to like share their screen online, I could make you a presenter and I could just take a look at your work or something like that. That's an option. Sarah, probably not before class ends, but I'm gonna let you guys work on them through the weekend. If you got some questions on anything lingering, we can do them at the beginning on Tuesday. Anyone want to check anything? I don't know, actually. You want to just skip another? Thank you. Let's see. We're definitely, no. Definitely not. So let's let me look at your answers for one and two. Yeah. That's what you want to compare. So what is 3 over root n do? Divergent. So eventually you're going to find that it diverges as well. I don't know if it tells you your DC. You can figure that out. LC. So you're going to have to compare it to something. You don't really have to multiply it out. You can drop the lower order 3 within the parentheses and just compare it directly to 1 over n cubed. Now which is bigger? Right. What? No, that's just the nth term test. That means nothing. You gotta use the p-test at this one. It's greater than a convergence. Just think about the logic, by the way. If you're dividing by, the things are getting tiny really quickly, right? So the bigger the exponent in there, the more likely that converges. So again, LCP, DCP, whatever happens. And then similar process go through for straight up. Yeah, that's the way it's going to go. All right. Well, there's a lot of chat. Holy mackerel. Okay, I'm going to just put up what the answers generally should be, and then if we need to work on them on Tuesday, we certainly can. The first one will diverge. LCT is what you're going to use there. Second one should converge. DCT is what you use there. This one, note there is no lower order term in number 3. So it's not a good idea to just say, let's compare it to 1 over n. And just like drop factors, because those factors are part of the largest order, highest order term. So in this case, LCT, DCT are probably not going to work too well. Instead, it's probably a good one for, what I want to tell you? Nah, I'll let you think about that one. And I'll let you think about the last one too. These are the ones that were the convergence tests. You can try the other two a little bit more thoroughly at home. Yep.
We look at the first one by p-test. Okay.
Well, you'll have to use the p-test to establish the comparison series.
What if I do it to like the actual?
To this?
Yeah.
But it's not in the right form, right? The p-series is of this form. Not a number plus n to the p. It's just 1 over n to the p. So it's gotta be this direct form, and that's why comparison tests will work. They'll drop the lower order terms, which make it not quite this, and then compare it to the thing that's exactly that. All right, so I see a lot of chatter in the chat. Yeah, so I don't want to just give you the answers. So yeah, try and work through the rest of it, get through the logic between 1 and 2 and figure out what to do for 3 and 4. And we will definitely take a look at them before we start on Tuesday. Actually, we have 2 days to do this lesson, so we're already basically done. So we can just work on these and other problems on Tuesday, more or less. All right. Sounds good. Well, try number 3. Think of all the methods that we've used and see if you can find the one that works. Otherwise, have a good weekend, and I'll catch you guys later.
Have a nice weekend.
Bye, Professor.
Later. If you want to see you later, Nicole. All right. Mike and Nora, you guys okay? Yeah.
Hey, Mike, can you send me the video? If you have a chance? If you're there. Never mind. Thank you, Professor.
He might be muted. He might not realize he's muted.
Oh,
Yeah.
thank you, Professor.
See you later.
Oh, yes, now I can. Yes, I am. Nora. Okay, thank you. All right,
Thanks so much.
bye.
Bye.